In the second half of section 3.9, we're going to be looking at the derivatives of logarithmic functions. And one thing you should recall from pre-calc 30 is that logarithmic functions and exponential functions are inverses of each other. So you can see here's the blue graph is y equals e to the x, and the red graph is y equals ln x, and they are symmetrical to the line y equals x. So if two graphs are symmetrical to the line y equals x, that means they are inverses. In calculus, we must be able to differentiate common logarithms and natural logarithms. A common logarithm would be one like log base 2 of some function, say it's x. A natural logarithm would be ln x. ln is really log base e, so instead of writing log base e, we just write ln. So to differentiate log base 2 of x squared, it's a three-step process. It is 1 over the function inside the logarithm, which is x squared, times the derivative of the function, which is 2, divided by the natural log of the base, which is 2. So divided by ln 2. If I was to simplify this x would cancel out one of those, and I'd be left with 2 over x ln 2. So here is the three-step process again. So it's 1 over the function times the derivative of the function over 1 over ln a, which is the natural log of the base of the function. Now our Calc 30 textbook has a different way of doing these. Instead of dividing by ln 2, they do it this way. So they would go 1 over the function times the function times log base 2 of the number e. Now log base 2 of the number e, if we use the change of base formula, would equal the same thing as 1 over ln 2. So we're not going to worry too much about this, but if you are reading the Calc 30 textbook, it's a slightly different approach, but it's really the same answer. Okay, let's take a look at our next example. So again, I want to use the chain rule. So the 3 stays out front. I'm going to bring that 3 out front. And log base 4 of x squared minus 5 drops to the power of 2. Then I must times it by 1 over x squared minus 5 times 2x divided by the natural log of the base, which is ln 4. So cleaning this up, I get 3 times 3 is 9 times 2 is 18x. I have log base 4 of x squared minus 5 all squared. And this is all over ln 4 times x squared minus 5, and that would be my final simplified answer. All right, in our next example, okay, we have y equals log base a of a to the x, and again, the derivative, if I did it the long way, because there's a shortcut to this one, would be 1 over a raised to the sine x times the derivative of a to the sine x, which would be a to the sine x, a to the sine x times the derivative of the exponent, which is cos x, times the natural log of the base, which is ln a. So there's 1 over the function times the derivative of the function, all divided by ln of the base, which is a. So if you notice, this will cancel out this will cancel out this, and my final derivative is just cos x. Now, there is a shortcut. If you remember from evaluating logarithms in pre-calc 30, if I have log base a of a to the sine x, if this base is the same as, let me just change this here quickly. So if this base is the same as this base, this whole expression just equals the exponent. So I could go right away and say this is really just y equals sine x, and then the derivative of sine x is cos x, which is the same answer. Okay, the derivative of natural logs is much easier because dividing by ln of the base, ln e is 1. It's just 1 over the function times the derivative of the function. So to take the derivative of this, it would be 1 over 3x times the derivative of the function, which is 3. And now the 3's would cancel, and my answer would be 1 over x. This question here, we have to use the product rule. So y prime is going to be the first function times the derivative of e to the 2x, which is itself, times the derivative of the exponent, plus the second function times the derivative of the first, which would be 1 over 4x squared times the derivative of x squared, or 4x squared, which is 8x. So simplifying, I get 2e to the 2x times ln 4x squared plus 4 goes into 8 twice, so these two are going to reduce to be a 2. I have an x on top and 2 x's on the bottom, so those are going to cancel. So I have 2e to the 2x over x. And notice I have two terms and I have a GCF, so I could factor a 2e to the 2x out, and I'd be left with ln 4x squared plus 1 over x, my final reduced answer. All right, in our next example, again, to take the derivative, f prime, it's going to be 1 over my function, which is x minus 4 divided by 3x plus 1, times the derivative of this, which is going to be the quotient rule, so 3x plus 1, times the derivative of the top, which is 1, minus the top times the derivative of the bottom, all over the bottom squared. So again, you're done calculus right here. 1 over any fraction, I can just reciprocate this fraction to get 3x plus 1 times divided by x minus 4. Distributing up top here, I get 3x plus 1 minus 3x plus 12 all over 3x plus 1 all squared. So now if I clean up, well, first of all, this guy can cancel out one of those. The 3 x's cancel, and I'm left with 12 plus 1, which is going to be just 13, and 13 times 1 is 13. And my denominator is going to be x minus 4 times x plus 1. One thing you want to be careful of when you do the 1 over, make sure you take the derivative of this inside and not this inside, because some people will flip it right away and they'll take the derivative of this as opposed to the derivative of what's in the original question. Okay, this was in a multiple choice from the 2003 exam. We're given the function. We want to calculate the derivative at 0. So the derivative is 1 over whatever the function is. So 1 over x plus 4 plus e to the negative 3x times the derivative of the inside, which is going to be 1. The derivative of 4 is 0, plus the derivative of e to the negative 3x is e to the negative 3x times negative 3. So now if I plug a 0 in, I get 1 over 0 plus 4 plus e to the negative 3 times 0 times 1. This would be minus 3e to the negative 3 times 0. So this ends up being 1 over, this is 0, 4. This becomes 1 because e to the 1 is, or e to the 0 is 1. So this is 1/5 times 1 minus 3, which is negative 2. So my answer works out to be negative 2/5. Okay, in the last example, we have a exponential function where my base is a variable and my exponent is a variable. So I need to use what's called logarithmic differentiation for this. So the first thing I do is I have to take the logarithm of both sides. Now, using my rule for logarithms, that x will come out front. And now I can take the derivative implicitly. So the derivative of ln y would be 1 over y times the derivative of y, which would be 1 dy dx. And on the right-hand side, I would have to use the product rule. So it's the first function times the derivative of the second, plus the second function times the derivative of the first. So this ends up being 1 times 1 over x, sorry, x times 1 over x is 1, plus ln x is 1 over y times dy dx. And now to get rid of the 1 over y, I'm going to multiply both sides by y, so this disappears. And I'll be left with y equals, whoops, oh, sorry, dy dx equals y times 1 plus ln x. Now, some people are tempted to stop there, but if this was a multiple choice question, if we go back to the original question, y is x to the x. So they would write their answer as that. So again, Logarithmic differentiation, the only time we use it is when we have a variable raised to a variable. Take the log of both sides, use your logarithmic rules, and then take the derivative implicitly. Okay, let's take a look at just question A here. We're given the function f of x is ln x over x, and we want to write the equation of the line tangent to the graph of f when x is equal to e squared. And they're also giving me the derivative here. So the first thing I need to do is find the y coordinate. So this is going to be ln e squared over e squared. Remember our rules of logarithms. I can bring the 2 out front. Ln e is 1. So my y coordinate is an ugly coordinate. It's 2 over e squared. So my point is e squared and 2 over e squared. Now to find the slope, it's going to be the derivative evaluated at e squared. Well, here's my derivative, so it's going to be 1 minus ln e squared over e squared squared. So this expression here is 2, and 1 minus 2 is going to be negative 1 over e to the 4th. So there's my slope, there's my point, and now I go to my point slope formula to calculate or find the equation of the tangent line. So it's going to be y minus 2 over e squared is equal to the slope, which is negative 1 over e to the 4th, x minus e squared. And because it's a free response question, we can stop right there. We don't need to convert this to any particular form. Okay, that ends the section 3.9 on logarithmic differentiation. So on the back of the handout of yesterday, you have some questions, and there's some textbook questions from your AP Calc textbook. So give those a try and see how you do.